Okay guys, how are you? I hope it is absolutely right. And in the continuation of our videos and for the calculation of the estimation regarding different coefficients of different components of an aircraft, we are just going to solve another coefficient which we have handled previously in one of our videos, but just to give an estimation of the exact coefficient, which is the side slip coefficient, which is represented by Cy of beta. I'll have to actually show you some of these steps, and also that may help us to get that relevant coefficient, which is the side slip coefficient. And we have learned about the steady coordinated turn, and we have learned about without any side slip, but we in that equation of motion, which is Fy, we learned that there was a component, or there was a part having the Cy of beta as well, with the aerodynamic component, or the aerodynamic force, having the aerodynamic forces or the property as well. For that reason, we have to actually solve out or estimate or approximate a side slip coefficient. For steady side slip maneuver level, obviously theta is equal to 0. We have learned because of the weight factor mg cos of theta sine phi is in the equation of force, which is the equation of motion. And because of that, we have to consider theta is equal to 0, and all the other factors Fy, P, R, and velocity is also equal to 0 as per the assumption. The same assumption, the Y force can be supplied as shown as figure. Obviously, when the force is 0, then 0 is equal to mg sine cos of theta, which is cos of theta is equal to 0, which is 1. So sine phi plus half p vt squared s, and just clubbing it into Cy beta into beta plus Cy lambda a into Cy lambda r into lambda r. And the Cyp equation is equal to 0. And also with the Cyr equation is also equal to part is also equal to 0. We have to neglect those two parts. For a small bank angle, which is phi, 0 is equal to mg phi, because normally we consider that angle of phi is less than equal to 10 degrees. So that reason mg phi, and it's just we have to put it that way, plus half rho vt or squared s, and just clubbing all together the same, and dividing both sides by this factor. Okay, so this would be 0, and this would dividing by this would be cancelled, and that would be here, and all would be here. For small phi, lift is equal to weight, because the angle is small phi, which is less than equal to 10 degrees, so the lift is equal to weight, that is L is equal to mg. And noting this is equal to, which is this is equal to C of L, and also obviously I'm replacing mg by lift, that would be half rho vt square of s. We get Cl phi plus Cy rho of beta plus Cy lambda a into lambda a plus Cy lambda r into lambda r is equal to 0. Okay, so generally Cy lambda a is negligible, and further, if we neglect contribution to side force due to rudder, please note rudder has dominating contribution to yawing moment. Okay, generally Cy lambda a is negligible, and further, if we neglect contribution to side force due to rudder, then that, because the dominating factor obviously is of rudder, and that is why we have to take that. Generally this one is negligible, we have to consider as 0, and further, if we neglect contribution to side force due to rudder, please note rudder has dominating contribution to yawing moment. Okay, so this is how we're going to calculate Cl of, because of this whole Cl, this whole would be Cl phi plus clubbing all together is equal to 0. This one would be equal to 0, and let's see what else the equation would let us know. This side force equation can be represented as this one. Okay, so obviously at the end of the day, the only factors that would be available would be this and this one would be 0, and lambda r, because certainly cy lambda is, and further if we neglect contribution to side force due to rudder, we have to neglect this as well. So these two would be 0. The only fair points would be this and this. So over here, what is this? Cy of beta is obviously the side slip coefficient, and we're going to obviously just manage it. Just solving out to the equation, we get Cy of beta, which is minus Cl phi by beta. The derivative Cy beta can be estimated with the help of Maillard values of Cl, and which is the lift coefficient, okay, phi and beta. The lift coefficient Cl is obtained through, which is obviously obtained through Cl. We're just going to solve it out for Cl as well. Not this, where we got Cl, we have got Cl, and obviously putting the Cl value on this one, we get solve this as well. Cy of whole or beta. Obviously, we have to calculate Cl on which is this one. Okay, so just putting the value of Cl, weight or equal to lift or equal to mg, that is altogether the same. So you just have to put the Cl value over here, and you get all the equation for the coefficient of side slip, or the Cy beta, which is the side slip coefficient. So what are the steps? We have to calculate the takeoff weight, and then we have to calculate with the help of the different instruments the values like bank angle. We have to calculate the phi, theta, beta, r, and also fy component. Obviously the assumptions are in front of us, but we have to actually assume that. Then afterwards we're going to calculate Cl, this one, and putting this value of Cl into this equation, we get the coefficient, which is side way coefficient. So this is a simple 4-step process just to get the side way coefficient. So I hope that with the help of this, we have covered different type of the coefficient related to the different parts of the aircraft, and whether we talk about generally when we talk about the fuselage, wing, or tail, or we have also discussed the drag polar as well, when we have talked about just talked about the Cessna 206H in one of our videos as well. You can go through that video and you can check that how the drag polar will be estimated or will be calculated or approximated with the help of the parameters given on the aircraft, with the help of the international standard atmosphere. We can have those calculations as well for the given atmosphere, for the given parameters, and we can have the drag polar equation as well, or the relevant coefficients as well. So it's a very I believe it's very conducive and also very productive videos that we have actually performed for the last couple of weeks, and also for the last one, especially when we are into this program of actually solving out for the aerospace and aerodynamics. And with the same approach, we're going to actually provide you the further concepts, further practical approaches towards understanding the different concepts related to aircraft engineering, whether we are talking as from the starting point as a student, or whether we are actually working as a professional. But right now, just to clear the crux of the concepts as a beginner, as a student, we will be able to actually provide you as much as possible videos as we can. And if you see any type of mistake, error, or which may be arithmetic error, which may be logical error, which may be engineering error, so you can point out straight away in the comment section. We will be happy to take that actually criticism in a positive way, and also we were going to rectify and improve, and also going to mention that this is the mistake that needs to be corrected for our viewers, for our actually students, or even for the learners like us who are actually into this airspace and aviation and the ATech technology. So I hope that with the passage of the time, if you see videos popping up, you can actually like, comment, subscribe, and also you can comment as per your liking. And also we have different sort of the services and offers as in the intro video of our channel, so you can check that. And also we have the pricing and plans videos as well. So if it's possible, you can just directly email, or we can negotiate on the different platforms, so that obviously we can help you provide the given services. So hope to see you again with some interesting and more thoughtful approach towards the aircraft, aerodynamics, aerospace, or aeronautical engineering. So let's see in a bit. I hope to see you again. Till then, take care and have a nice day.